Greetings everyone. We will continue our discussion on our information retrieval systems. In the last session we have discussed about what are the information retrieval system and the domain analysis of the information retrieval system. In middle we have stopped about the domain analysis of the information retrieval system. In this particular session we will continue about that domain analysis. So in the session we will complete the domain analysis of information retrieval system. I told you some facets, all those facets will be covered in this particular session. If possible, we'll go for other information retrieval systems and how to evaluate an information retrieval system. So coming to the previous session, so I have told you the facets of particular information retrieval system. We'll be having the set of facets, that is the conceptual model, the file structure, the query operations, the term operations, the document operations and the hardware. So all these facets have been described to you in the last session, and in depth I have told you about the hardware facet. As part of the hardware facet, I told you what is a one Neumann architecture. So in that one Neumann hardware will be having a system with one particular processor, with only one processor. As a result, we'll be having a particular speed of one processor. And I told you about the parallel processing, so where you can be having more than 16,000 processors in our particular system, so that you will be providing a high speed information retrieval system. And I told you IR specific, where you will be having hardware specific to information retrieval systems, and we can be having optical disks or magnetic disks to store large amount of data and large types of data, okay, and various types of data. So all these things are a part of the hardware facet. So your information retrieval system could be using one of these hardwares to store your information and for faster accessing of your particular data present in the hardware. Okay, we'll be looking at other facets one by one in the following slides. So first we'll be looking at the next facet, what is the file structure. I think while learning your database management systems, you should have known what is a file structure. Basically, you have to remember that the hardware is nothing but the memory, that is what type of memory you are going to use at the background and what is the particular memory type, what are the number of processors you are using, okay, what type of memory you are going to use for the storage. That is hardware. Okay, once the above level of your hardware will be your data file structure. So in database management systems, you must have learned about your file structures. Okay, these file structures will be used to what we will be calling it as how to store in your store files in your particular database. Okay, so the file structure. So file structure, the fundamental decision in the design of your IR system is which type of file structure to use for underlying document database. Okay, basically how to decide, the first decision should be what type of hardware you are going to use. The second decision should be which type of file system you are going to use as a part of this information retrieval system. Okay, so hardware will be closely interacting with the file system. Okay, the file system will define how your files will be stored in your particular information retrieval system. So the file structures used in information retrieval system are, we could be either using flat files, inverted files, signature files, fat trees and graphs. Okay, so all these types of terms could be used as a file types in your particular information retrieval system. So either you'll be implementing flat files or inverted files or signature files or fat trees or graphs. Any one of this particular thing could be used as file system in your particular information retrieval system. So we'll be looking at all these things one by one. So the first thing is, using a flat file approach, one or more documents are stored in a file, usually in ASCII or other general text coding formats. Okay, so using flat files, you will be storing your documents in your flat files, or what you can see generally in your computers. Those things will be calling them as flat files. Okay, they will not be having any clear organization, just they will be files. In these files, you can be storing your particular data in either ASCII text or any other text. Example, either in your Unix, you will be storing all the files in flat files. Okay, whatever search you want to do in Unix, you will be using either some grep systems or other systems. Okay, grep commands, awk commands you could be using in Unix for searching some content in those files. Okay, so in that particular Unix, we will be using flat file system or flat file structure to store your particular files. So your IRS system could be using flat file system also. Okay, so if your IR system is not much complex, it is having just a text, then you could be using flat files to store that particular text. Okay, so other things, that is your inverted files, signature files and path trees are also used as your file structures in your information retrieval system. For the time being, I will not be discussing them. As you already know, you will be learning inverted files in your second unit, you will be learning about signature files in your third unit, you will be learning path trees as your fourth unit. So all these things, that is whatever you are going to learn in further units, will be your particular file systems. That is how you are going to implement these file systems and how you are going to use this file system to store your data in the database. Okay, so those are the file systems which you will be having in the further units. For the time being, there will not be much discussion about flat files. I think you know how you will be having flat files in your Unix system. Okay, another last one, whatever the file systems you have, that is graphs or networks, which are orderly collection of nodes connected by arcs. They can be used to represent documents in your numerous ways. Okay, basically graphs, I think you know. So the graph will be having nodes and arcs. Okay, nodes are these nodes will be represented as what we will be calling the documents can be represented as nodes here, and the relationship between the documents can be represented as arcs here. Okay, so basically this thing also could be used to implement your file system in a particular database of information retrieval systems. But these graph-based techniques are impractical now, because the amount of manual effort that would be needed to represent a large number of documents as a graph or nodes will be very hard for you to implement that particular thing. Okay, basically this was somewhat older one, that you could implement your particular information retrieval system file structure by using graphs, but so the manual effort will be very high to represent each and every document as a node, and to find the relationship between each and every document and find arcs between each and every document. So that will be a hectic process for you to implement a file structure. Okay, so that is why this has become impractical now. So you are not be using this, what we will be calling it as graph file system in information retrieval system, but you are having that option of implementation. If there is an application which you can implement by using this one, you could implement. So basically these 5 different systems are present, or file structures are present as a part of your information retrieval system. Either you could be using a flat file just like in Unix, or you could be using inverted files, signature files or path trees to implement the file structure. You will be learning about them in the next session. Next, you could be implementing graphs or networks as a part of your file system. Okay, this is the file system terms we have. Okay, next this is an example I gave you in the last session. In the last session I told you about what is the hardware used in your catalog IR system. So the hardware used in your catalog IR system is the one human architecture for your with one processor and magnetic disk to store your particular data, and the file system or the file structure implemented by the information retrieval system, or that is your catalog information retrieval system, is your inverted files. Okay, we'll be learning about that inverted files in the next unit. For the time being, know that we are going to implement this particular thing. So the catalog IR system will implement this particular file system. So we'll be looking at these things some more session, next topics. Okay, so far I have covered the hardware and the file structures. The next one we'll be looking at is the conceptual model. So the conceptual model is the general retrieval approach of your information retrieval system. Okay, so by this time you should be saying what are the parts you are doing. So I told you already, each and every information retrieval system could be doing 3 things mainly. The first thing is collection of data and storing that particular data. So that will be the hardware part, and organizing that particular data, that will be the file structure part. And now the information retrieval process. The information retrieval process will be the part of your conceptual model. So the conceptual model is basically about the retrieval approach of your information retrieval system. That is how you are going to retrieve your particular information from the IR system. Okay, several taxonomies have been proposed for this purpose, but the basic approaches which any information retrieval system will use is either you could be doing a text pattern search, that is when you are searching for a text, will be using a text pattern search, or you could be using a inverted file search, that is you could be searching in an inverted file, you'll be learning about that later, or you could be doing a signature file search, that is you could be searching in a signature file. These are basic basic approaches of your retrieval, but we'll be looking at them later onwards. For the time being, know that your conceptual model will be having several taxonomies, that is classification is done in several ways. So this is a basic thing, 3 approaches will be present in several systems, but I will not be looking at these 3 searches, we will be looking at another taxonomy. So the retrieval techniques which are present in information retrieval system are broadly classified in this manner. Okay. So as you could see, all the retrieval techniques are divided into 2 types. One is exact match, another one is inexact match. Okay, so your retrieval system could be either an exact match retrieval system or it could be an inexact match retrieval system. So whenever you type something, for example, if you type one word, okay, so and you are searching for that word. So if that particular word is present as it is in the document, then we'll be calling it as exact match search. That is, you are searching for a particular word in exact terms. That is, that particular word should be present completely. And inexact search will be, inexact match search would be, so that word might not be present but the related words could be present. That would be calling it as inexact match search. So if any related words are present, it could be retrieving those documents also. Such search will be calling it as inexact search. So exact search would be done either by using text pattern search or Boolean search. So both these terms, both these things are your exact searches where the document should contain whatever the keyword you are searching for. Okay, these 3 things are inexact searches. We'll be looking at them one by one. That is, what is text pattern search, what is Boolean search, what is probabilistic search, what is vector search, and what is clustering search. Okay, we'll be looking at them one by one now. So basically remember that all the searching techniques are your retrieval techniques will be divided into 2 types. One is exact match search, another one is the inexact match search techniques. So exact match searching techniques will be Boolean and text pattern search, and inexact match search would be probabilistic search, vector search, and clustering search. So we'll be looking at them one by one. So the next, almost all the information retrieval systems fielded today are either Boolean information retrieval systems or text pattern systems. Okay, so most of the information retrieval systems will be in this manner. Okay, but there are other things, that is inexact match searches also are present. I will show you one by one. So first we will be looking at what is the text pattern systems. Okay, text pattern systems are more common for searching small collections. As you could see, they are mainly used for searching small collections such as personal collection of files. Okay, personal collection of files. If you are doing some search in your particular system, generally if you will be searching for some particular word in your MS Word, that would be your text pattern search. Okay, this text pattern search would be usually done whenever you are having small collection of data items, or you could be searching for a particular text in one document. Okay, those things will be smaller things where if you want to search for smaller collections such as your personal files, okay, there will be using text pattern search. Okay, in text pattern search, this will be used in your basically Unix environment, as I already told you. So this Unix environment will contain your grep commands, okay, or AWK commands. So these grep commands will be used to retrieve data or retrieve your, it will be searching for some text in your particular document. Okay, so your text pattern search will be used in local systems usually, but if it want to be implemented in information retrieval system, it could be done easily. But whenever you are dealing with small collections of data, then we'll be going for a text pattern search. Okay, the text pattern search is an exact word search, so whatever the word you are giving or whatever the keyword you want to search should be matching in your particular document. If that particular word is not present in the document, it will be giving you otherwise. Okay, that is what we will be calling it as an exact match search. So your text pattern search is one exact match search. It will be done for small collection of documents and it is used as an example. Okay, as an example, it is used in your Unix environments as grep commands. Okay. So the next one, that is Boolean systems. So almost all of the information retrieval systems for searching large document collections are Boolean systems. Okay, for searching small collection of items, we'll be using the text pattern search. For searching large collection of items, we'll be using Boolean systems. Okay, in a Boolean information retrieval system, documents are represented by a set of keywords usually sorted in an inverted file. So all the documents, so whatever the documents you are having as a part of the information retrieval system, so are represented by a set of keywords. So for example, if you are having one document about the information retrieval system, that document should be having some set of keywords. Okay, the keywords could be, one keyword will be information, another keyword will be retrieval. So these two keywords represent that particular information retrieval system document. For example, if you take this presentation is one document. This presentation will be having its own set of keywords. The set of keywords could be the domain representation, or you could be using the Boolean system, or you could be using the conceptual model keyword, or you should be using the IRS keyword. Okay, all these things will act as a keyword for that particular document. So in any sense, in the future, if you are searching for a particular word, that is, if I am searching for Boolean systems in future, so this document could be retrieved. Okay, so basically any Boolean retrieval system will contain documents, and all the documents are represented by set of keywords and are usually stored in an inverted file. Okay. An inverted file is a list of keywords and identifiers of the document in which they occur. So all the keywords, okay, whatever the keywords you have identified for a particular document are stored in the inverted file. So basically an inverted file, a small introduction to you, an inverted file is a list of keywords and identifiers of the documents in the system. Okay, the inverted file will basically contain what are the keywords present in your particular complete IRS system, and what are the related documents present for that particular keyword. Okay, that is how your inverted file will be present. So the Boolean system mainly contains documents. Those documents will be identified by identifiers, and each document will be having its set of keywords. These keywords and document identifiers are usually stored in an inverted file thing. So this file will be searched for particular documents. So basically you are going to search for the inverted file, and that particular inverted file will contain a keywords, and regarding a particular keyword will be having a set of documents. All those documents will be retrieved in your search. Okay, that will be your answer list in your information retrieval system. Okay, so we'll be seeing some more things about this thing. So researchers also have tried to improve your information retrieval systems by using information about statistical distribution of terms. Okay, statistical distribution of terms, that is the frequency with which the terms occur in documents. Okay, so not only about the Boolean system, researchers tried to improve the performance of your information retrieval systems by taking the frequency in which the terms present in a particular document. For example, how many times information retrieval is present in this particular document. That would be the frequency. Okay, in the similar sense, all the documents will be scanned for a particular word. That is, how many times information retrieval is present in all the documents. That frequency will be noted here. Okay, so that statistical distribution will be used. Okay, document collections or other document collections, such as documents considered relevant to a query. For a particular query, which are the documents related to this particular query. So basically what you need to do is, for a particular keyword, okay, how many documents are having the relevancy. For example, as I already told you, if I am searching for information retrieval keyword, if I am search for that particular thing, how many documents are having information retrieval? Among these documents, what is the frequency of that particular information retrieval in the particular document? Okay, how many times the information retrieval keyword is present in the document? That frequency will be noted in a particular file. Okay, so that things will be present in your what we'll be calling it as the vector space model, the probabilistic model, and the clustering model. Okay, as I already told you, these three models are what we call inexact match models. Okay, whenever you are searching for inexact things, we'll be searching for the probability of the match. Okay, at that time we'll be looking at the probabilities. So the term distributions, whatever you have seen in the previous slide, the term distribution or your probability of a particular word to be present in the document are exploited by these three methods. Okay, all these three methods will be using those term, okay, probabilities. So using this probabilistic model and information about the term distributions, it is possible to assign the probability of relevance to each document in retrieval set, allowing your retrieval documents to be ranked in order of probable relevance. As I have told you in the previous slide, if you take an information retrieval keyword and if you search for that particular keyword in all the documents, and you could find some set of documents will be having high relevancy and some set of documents will be having low relevance, based upon the frequency of that particular word present in the particular document. So based upon those relevancy, that is how many times the particular word is present in one document, you can be giving you some probability. So all these probabilities can be made and it could be used to rank each and every document. Okay, this will be calling them as ranking algorithms. Okay, ranking algorithm basically use this term frequencies to identify the particular term is present in a particular document or not. So if it is present, how many times it is present? What is the frequency of that particular term present in the particular document? So all these things will be used to rank the documents based upon their relevance. So these relevant documents could be written by your particular information retrieval search. Okay, whenever a particular word is not present, that is, if you are searching for information retrieval word, some particular things will be, some particular documents could be containing only information word. Some particular documents can be containing irrelevant words, that is, it could be containing other words, relevant words. At that time, the probability of your particular documents will be noted. So based upon the probability only your search results will be present. Okay, so based upon this probability only a ranking will be done to each and every document in a store, and based upon that ranking only your results will come as a search answer list. Okay, so these things will be using your term frequency to identify the probability of that particular document and to identify the relevancy of that particular document for a particular query, and based upon that we'll be giving the rank to each and every particular document in the database. Okay, so among these, the ranking is useful because of the large document sets that are often retrieved. Okay, so we'll be retrieving large number of documents. Among these documents. So to find out which are the most relevant documents, you have to rank each and every document. This ranking will be done, as I told you, by using the term frequency present for your document. Okay, the ranking algorithms are used in vector space model, probabilistic model, and the clustering model. Okay, all these three models will be using this particular ranking algorithms. So by this time you could be understanding, I told you about the two types of methods you have, that is exact match search and the inexact match search. The exact match search is about your text searching, that is text pattern searching, like in Unix grep commands. Next, the Boolean search would be about whether you want to find the particular document in the particular file or not. So we'll be using that particular document with set of keywords. All those keywords will be stored in inverted file. We will be searching the inverted file for a particular document. And inexact search will be about finding out the term frequency for each and every document and using the ranking algorithm to rank each and every document from top to bottom, and among these things which are ranked higher will be having high relevance to your query. So what are the documents which are having high relevance to the query will be retrieved by your information retrieval system. Okay, this is how your conceptual model will work. So the example, will come back to the example. So your catalog IR system will use the Boolean conceptual model. So as I already told you about the Boolean conceptual model, you could have remembered now. So Boolean conceptual model is about taking your documents and finding out the keywords of those documents and storing those keywords in an inverted file, and whenever you are searching for that thing, you search in the inverted file for a particular keywords, and those keyword matching documents will be retrieved by your information retrieval system. So your catalog IRS system will be using the Boolean conceptual model. So far we have seen the three things, that is the first one hardware, okay, we'll be using the von Neumann and magnetic disk. Second one is the file structure, we'll be using the inverted file. So the third one is the conceptual model, the Boolean. So the Boolean and the inverted file are interrelated here. You could know, so you should be understanding this thing. The Boolean particular conceptual model will be using the inverted file to store the keywords of the particular documents present in the information retrieval system. The next thing, the next facet we are looking at is that what are the document operations which are supported by information retrieval systems. So the documents are the primary objects in your information retrieval systems, and there are many operations which will be supported by the particular system. So the set of operations which will be usually supported are, the first thing is the parsing, the second is the display, third clustering, fourth ranking, fifth one sorting, sixth one field mask, and seventh one assign ID. Okay, among these things the main important thing is assigning ID. Okay, next will be important thing is the displaying of your particular files, next sorting your files, ranking your files, and parsing and mask will be other things. We'll be looking at one by one now. So the first one, in information retrieval systems, documents added to the database must be assigned one unique identifier. Okay, each and every particular document will be having one unique identifier. So using that unique identifier only, we should be able to identify a particular document in the information retrieval system. Okay, so whenever the document is collected into the IRS system, we have to give one name or ID. That assigning ID is one operation. It should be supported by the documents present in IRS system. The second thing is parsing. Once after getting the document in the system, we have to parse the particular document into their constituent fields. So each and every document will be having a set of fields. So we have to identify those fields, and these fields have to be separated again, and these fields also have to be having its own field identifiers and terms. So the parsing part is nothing but knowing the context of your particular document and what are the terms which are present in the document. Based upon those terms, we have to identify the fields of that particular document and separate them. So this is the thing which has to be done as a parsing part. So your IRS system will also be supporting parsing, not all systems. Some systems should be supporting the parsing part. So this parsing part mainly involves taking your document and finding its constituent fields, that is what are the fields present in your document, and breaking down those fields into fields and give identifiers to those fields also. That is the part of parsing. The next thing is, once in the database, sometimes you wish to mask of certain fields for searching and display. Okay, while searching, if you are searching for something, in the parsing part, you have given fields and field identifiers. In some cases, you want to mask these fields, and if you don't want some terms to be identified by everyone. So if you want to mask some parts of your particular file for searching and other displaying part, you can mask the particular thing by using the mask operation. This also will be supported by the documents. Masking means basically if you don't want some operations or some particular files to be not to be seen to the searching, then we can mask the particular thing. The next one may we also wish to sort your retrieval list. Okay, whatever the list of files you have retrieved from your search could be sorted. So sorting also will be supported by your IRS system. Next, display operation will include printing the documents and displaying the documents on the monitor. Okay, so display is basic thing. How to be able to, you should be able to either display the particular document or you could be able to print those documents. Okay, so next one, based upon the information I have already told you regarding the ranking algorithm, based on the information present in the particular document and the frequency of the particular words present in the document, you could be ranking your particular files according to the rank. Okay, particular documents according to the relevancy of a particular search. Okay, last one, once after retrieving some particular files, you want to group some set of files only relevant to particular search. You don't want to retrieve each and everything. You want to group only a particular set of things, then we'll be dealing with a cluster particular thing. cluster documents. So these are the operations supported by your documents. So the first operation is giving you the unique identifier to each and every document. The second operation is parsing the particular document into fields and field identifiers. The third one is masking of some fields or some things for searching and other operations. Next, the fourth one is sorting your retrieval list. The fifth one is displaying your retrieval list. The sixth one is ranking your retrieval list based upon the terms. And the seventh one is clustering a similar set of documents into one cluster. These are the operations supported by documents in IRS system. Coming to our example, the list of operations or documents supported by your catalog IRS system is, it will be supporting all the particular operation. That is, it will be supporting parsing, it will be supporting display, it will be supporting sorting, it will be supporting mask and assigning IDs. All these things will be supported by your IRS system. So in this session we have looked at the three particular facets of your model. That is, we have looked at the file structures, we have looked at the conceptual model, and we have looked at the document operations. In the next session we will be looking at the term operations and the query operations. After that we will be looking at what are the different IRS systems we have and how to evaluate an IRS system. We will wrap up this session now, and we will continue about the remaining facets of your particular IRS system. Thank you.